All right, so the question is to graph y equals to 2.8 cos of 5/3 bracket x plus 60 plus 7. And in order for me to do this graph, I'm going to relate it to another graph that I am very familiar with. I'm going to relate it to the original function y equals to cos of x. And so when I graph a shifted or a transformed function, I'm always going to graph my new function in relation to the one that it comes from, or the one that it stems from, because I know that cos of x goes from -1 to +1. I know that the range of values for the y variable is from -1 to +1, and I know that the length of one complete cycle, the length of one full revolution, is from 0 to 360 degrees, or if you're using radians, it's going to be from 0 to 2 pi. So one full cycle of the cos function is going to start at 0, 1. Let's graph it here. From 0, 1, that's the maximum value, down and up again to 0, 1. That's how long it takes to get back to its back up to its the end of its cycle, and that's not going to be at 0, 1. Sorry, that the end of the cycle is going to be at 2 pi comma 1, or 360 comma 1. That is the end of its cycle, and of course you know that at the halfway point it's going to be at 180 degrees, and then halfway of that is going to be 90 degrees, and so on. So everything is going to be in relation to this this curve. And so the first thing that I'm going to deal with is the 2.8, the amplitude. So let's talk about the amplitude. The amplitude is equal to 2.8. And what that means is that for the original function, the amplitude is 1 unit. And so for my new function, the amplitude will be 2.8 units. So instead of going from -1 to +1, it's going to go from -2.8 to +2.8. But I have another problem. The other problem is that I have also introduced this variable, this parameter here called +7. So what that means is that I am doing a shift upwards of 7 units on the amplitude of my deviated, let's call it the adjusted function, or the secondary function. So instead of going from -2.8 to +2.8, which is what it would be if it was at the center, it needs to be shifted upwards 7 units. So what we're going to do is we're going to add 7 to this and add 7 to the upper limit. So add 7 to the lower limit and add 7 to the upper limit, which means that our function will have a channel or a range of values. Okay, remember that we talked about the channel of values, and that channel of values is going to be from 2.8 plus 7, which works out to 4.2, all the way up to 2.8 plus 7, which is 9.8. Sorry, I meant -2.8 plus 7. So it's going to go from 4.2 to 9.8. 4.2 is going to be the minimum value, and 9.8 is going to be the maximum value. So that's great, because now I know that all of my values are going to be plotted in that range of 4.2 to +9.8. What's the next thing that I need to deal with? The next thing that I need to deal with is the length of the cycle. So how long is one cycle, and what is the parameter that deals with the length of the cycle? Well, let's go to our next page here. Remember that the curve is going to be y equals to a cos of bracket b bracket x plus c, close it up, plus the d. Those are my parameters. So what controls the cycle? The cycle is controlled by the b variable. And so what is the b value in our case? The b value in our case is 5/3. So what is our cycle going to be for our new function? So instead of having a 2 pi radian cycle, or 360 degrees cycle, we are now going to have 360 degrees divided by 5/3, whatever that number is. Or you could also use 2 pi divided by 5/3, whatever that value is. They're going to be the same numeric value. Of course, one is in radians and the other one is in degrees, so be conscious of that. Well, I'm going to use degree mode, so 360 degrees divided by 5/3 works out to be a value of 216 degrees. So this works out to be 216 degrees, which is great. Now I know that the cycle is going to be 216 degrees. And if I want to go for 2 full cycles, then I have to make sure that I cover at least 2 cycles. So I'll remember that you need to have 2 full cycles. And 2 full cycles means that you've got to cover at least 432 degrees. So you've got to include your graph to have at least 432 degrees in your graphing domain, if you want to call it that, because the domain is the x values. There's one more thing that we forgot to talk about, and that thing was the c. And how does the c affect your adjusted graph? Well, the c variable, in this case, c variable is 60 degrees. And so what that means is that our graph will be shifted vertically, it will be shifted horizontally. In what direction? It'll be shifted horizontally in the left direction because c is positive 60. So it'll be 60 degrees to the left. So it's not going to be starting at 0 degrees, it's going to start at, our first cycle is going to start at negative 60 degrees. So our first cycle starts at negative 60 degrees, which is fantastic because now I know that if our first cycle starts at negative 60 degrees and one cycle length, let me see, spell that right, one cycle is equal to 200 and how much was it? It was 216 degrees. Then that means that our first cycle is going to end at, well, let's see, it's going to end at negative 60 plus 216 degrees. It'll end up at 156 degrees. So the first cycle starts at negative 60, ends at 156, and the second cycle will end at 156 plus 216. It will end at 372 degrees. So now let's see if we can sketch this. We've got as much information as we need. So we've got our our axes, and our x-axis and our y-axis, and we know that the minimum value is going to be 4.2. We've already established that the minimum value is 4.2. The maximum value is 9.8. 9.8. There's our channel of values, 9.8. And what's the halfway point between 9.8 and 4.2? I need to know that because that's going to be my mid-range, my mid-range, or the middle of my range of values. Well, let's calculate that. Well, that's pretty easy because 9.8 plus 4.2 adds up to a total of 14. And 14 divided by 2, the average is 7. And no wonder it's 7. It's 7 because we've shifted it up 7 units. And so the middle of the range is 7. And now we can start doing our plots. And remember that our original function started at a high point, at a maximum, and then moved downwards. In our case, we're going to start at negative 60 degrees, so we have to go to, say, minus 60 degrees, and then it's going to finish that cycle at positive 156, because remember, each cycle is 216 degree cycle. Okay, so we're going to end it at 156, wherever that is. Let's just ballpark it here. I'm not using proper graph paper here. So it's 156 degrees, 60 degrees, and the end of that cycle is going to be at 372 degrees. So there's our 2 cycles. And in order for me to plot this, you have to recognize that it starts at 1, at the highest point, and then it crosses, goes back up to the highest point at 156, and then goes back up to the highest point at 372. So what happens in between? Well, let's see. halfway between negative 60 and 156 is going to be at a minimum. Halfway between 156 and 372, again, it's going to be a minimum. And now I can join these and create my curve. As much, making it look as much as a cosine curve as I possibly can. And there you go. So there's our curve. Now, along with that, as you can see that the domain is x is an element of reals. There's no restriction to the x values. They can be any real number. The range is between positive 4.2 is y is an element of the reals, such that 4.2 is the minimum value and 9.8 is the maximum value. So there's our domain and range. And what I'll do is I'll append to this email a graph for you.